Don't forget to subscribe and ring that bell.
And we are on to video 4. We did 1 through 8. We did 9 through 16. We did 17 through 24. Multiple choice is done, man. We are on to the January 2023 Algebra 2 Regents High School examination. Short answer questions number 25 through 32. All right? Let's get these. Let's get them. First off, let me start by saying these 8 questions are still worth 2 points each, but you can get partial credit here. So show work where it's definitely appropriate. Don't skip things out. Now, if for some reason you don't know how to do it algebraically, but can still do it in the calculator and get the right answer, do it. Write down the right answer because you still get 1 point for having the right answer without showing any work. Let's go. Just factoring. I tell my students, factoring never goes away. Pre-calculus and calculus, you still factor. 25 says that algebraically determine the zeros of the function below. All right, if you do it in a calculator and just have the right answers, you get 1 point. Okay, but factor by grouping, kids. Let's do this. Okay, I'm going to factor these so that what's left in each parenthesis matches. Meaning, I'm going to take a GCF out of this purple here. It's going to be 3x squared. And when I do that, that's dividing both by 3x squared. I'm going to end up with x plus 4. And what I want to do on the right side is I want to take something out so I end up with an x plus 4. I want these two to match. Okay, so I've got to take out a negative 3. Not a 3, but a negative 3, because I want to flip both of those signs as well. So I take out a negative 3. I get 1x plus 4. Good. All right, so now the whole point here in factoring by grouping is these two will go in one parenthesis on their own. Okay, so I've got 3x squared minus 3. And then what's left here, I only have to write it once. Okay, that's my x plus 4. Now, for a 2-point problem, they slipped in another bit of factoring. What do I mean? Well, I could take a 3 out of here. So I'm going to take out a 3. That leaves me an x squared minus 1. And we have x plus 4. Oh, tricky. Now they have adopts. This is a difference of perfect squares. That's x plus 1 times x minus 1. And then we have x plus 4. And don't forget the 3. This is factored completely. Okay? Oh, algebraically determines the zeros. Holy cow. Look at me. I got to solve for each one of these. If I set this equal to 0, my x will be negative 1. If I set this equal to 0, my x would end up being a positive 1. And if I set this equal to 0, my x will be a negative 4. And yes, I was not wrong. Okay? This is factored completely. I just didn't finish answering the question. Those are my 3 zeros. All right, great problem here. Given that a is greater than 0, solve the equation a to the x plus 1 equals the cubed root of a squared for x algebraically. I'm going to remind you all that when I have, we'll call this an f over v. When I have an exponent as a fraction, we do top down, bottom out. What does that mean? My top just slides down, and my bottom pops out of the radical. So I'm going to take this and put it back into a form where my top just slid down and my bottom popped out. Okay? Top down, bottom out. Take it for what you will. This side did not change. Now, if, kids, if the bases are the same, the exponents have to be equal as well. They have to be the same. So I'm just going to subtract 1 from both sides. And if I do this in the calculator, I get negative 1/3. And hi, ho, ho, everybody. That was an easy one compared to 25. We're done. Number 27. If the probability of A is 1/3 and the probability of B is 5/12, where A and B are independent events, determine the probability of A and B. This symbol means and. This symbol means or. Okay? If I have two things here and they give me both of them, the probability of B and the probability of A, and I want them both to happen, that means I need to multiply them. Okay? If they had the or, it would mean I would add them. Okay? In this case, we're multiplying. So it's literally 1/3 times 5/12. If this was an or, I would just add them. But I multiply them. You have a calculator. There's no reason you shouldn't be able to do this. That was a sickening, easy problem. You're welcome. All right, now we're going to get to use a calculator. The scores on the Collegiate Mathematics Readiness Assessment are approximately normally distributed. I can never get used to that. With a mean of 680 and a standard deviation of 120. Determine the percentage of scores between 690 and 900 to the nearest percent. My answer should not be a rate where it's a decimal. It should be a percent. Maybe it's a decimal with a percent, but guess what? We're rounding to the nearest percent, so I should not have a decimal in my answer. Okay? Normal CDF. What am I talking about? In your calculator. Okay, and you get this correct by writing this down, okay? You see above, okay, above VARs in blue, it says like distribution, normally distributed. See how it says distributed? We are going to go to second VARs, and we're going to pick normal CDF, not normal PDF, normal CDF, okay, which is choice 2. And when I pick this up, boop, it's going to ask me for a lower bound and an upper bound. This smushed M means the mean. That's actually this thing smushed together. That's the mean. And this little pigtail thing is the standard deviation. So what I'm going to do is I'm going to go to my problem and say, all right, they tell me the mean is 680 and the standard deviation is 120. That's nice. But what do they tell me? They want the scores between 690 and 900. So 690 is going to be my lower bound, and 900 is going to be my upper bound. So I'm going to go from 690 to 900. My mean was 680, and my standard deviation was 120. I'm simply going to paste this into the function. And all I've got to do is write this. That's normal CDF, it says. Okay? There you go. That's it. So as part of my work, I'm going to say, ooh, normal CDF. Okay? I put my lower first, which is 690. I put it in the order the calculator did. This is my lower limit and my upper limit. This is the interval that I'm checking from 690 to 900. They then want my mean, which is 680. Oops, And then they want my standard deviation, which is 120. And when I hit enter, it's 0.4334. That's a proportion, a decimal. I multiply it times 100 to make it a percent. It's 43.34%. And they want it to the nearest percent, which is whole number. 43% of my scores. of this math readiness assessment are going to fall between 690 and 900. 29. Looks like we're using the calculator again, and I love it. Consider the data in the table below, and they give us 6 x values and the corresponding 6 y values. State an exponential regression to the model, rounding all values to the nearest thousands. That's 3 decimal places. That doesn't mean cut off. That means round your third place. Okay? Whenever they wanted a regression, I mean, easy. I go to Stat, and I pick under Edit, Choice 1, just Edit, and I put all my x's in L1. I had 1, 2, 3, 4, 5. Did I have 6? I have 6. There you go, 6. And then in L2, I put my y values. 3.9 is the 1. That goes with an x value of 1. 6 goes in the x value of 2. 11, 18.1, 28, and 40.3. So I'm just going to look at these quickly, make sure I didn't miss a number. The decimals are all there in the right places. Good, we're good. Because they tell us in exponential regression, okay, because there are several types of regression. Okay, now I'm going to go back to Stat, and I'm going to calculate a regression. I'm going to scroll down until I see exponential regression, which is choice 0, expreg. Okay, exponential regression, right there. Hit Enter. Keep on hitting Enter until I calculate. Enter. There you go. Okay, they want this rounded to the nearest thousands, which is the third decimal place. This 8 will become a 9 because the number after it is 5 or bigger. And this 5 will become a 6 because the number after it is 5 or bigger. So notice that my A is going to go here. So y equals 2.459 times. So you can use a parenthesis or you can write times. It doesn't matter. I'll do the parenthesis. My B value, 1.61, that's going to be a 6. 1.616 to the x. That's it. That's all they wanted. Man, that was money. All right, number 30 is going to bring us back to algebraic calculations and manipulations. Write the expression a to the x times b to the x minus 3 times c to the x as a polynomial in standard form, which means I just got to mangle everything together and just write it as one equation. All right? So I need a of x first, which is this. So I've got x cubed plus 2x minus 1 times b of x, x squared plus 7 minus 3 times c of x, which is x the fourth minus 5. All right, well, let's do some math, kids. Okay, I'm going to distribute my x squared. X squared times x cubed, well, that's x to the fifth. X squared times 2x, it's plus 2x cubed. And x squared times negative 1 is just negative x squared. Now, I've got to multiply my, ooh, we're going to get crazy here with the colors. My positive 7. Positive 7 times x cubed is positive 7x cubed. I'm going to write these so I kind of line them up. Okay, 7 times 2x is 14x. I don't have any, so that'll just be here to the side. And last but not least, oh boy, let's go this pink. 7 times 1 is just a negative 1, is just negative 7. So this whole thing right here, when I combine it, will give me x to the fifth plus 9x cubed minus x squared plus 14x minus 7. And I still got to distribute this 3 here, negative 3, minus 3x to the fourth plus 15. Now, all I've got to do, I mean, at the point where I just combine like terms, I have an x to the fifth, and I have no other x to the fifth. Okay, I now have, okay, I have here a minus 3x to the fourth and no other x to the fourth. All right? Let's go cubes. Why do I feel like I'm missing something? No, I combined it all already up here. I did my combining over. So that's 9x cubed. Okay, x's. I just have 14x, so plus, I got to do x squared. Oh boy, look at me go. Minus x squared. All right, well now I do my x's. I just have right here plus 14x. And last but not least, I have a minus 7 and a plus 15. 15 minus 7 is plus 8. Is that a 15x? Did I make a boo-boo somewhere? Oh, I did. You see up here for C? That should be 5x, which means negative 3 times 5x is 15x. Oh, boy. What a boo-boo that was. Good thing I caught that. So I really only have my minus 7. That's the only term I have. But for my x's, I have my 14x and my 15x, which is going to give me 29 x's. Wow. That was a really good catch. Okay? They say, do we need the equation? It says, write the expression as a polynomial. It doesn't say polynomial equation, but if you're freaked out and you just want to put y equals, you can. I don't think you need to in this situation because it does not say equation. And we're good to go. Woo! Good catch. I hate when they ask us things like this, but they do, whatever. All right, so you might freak out because there's a 4 and a 2 there. Otherwise, completely factor, this looks like, let's say this was a 2 and a 1 for my exponents. I handle it the same way. What adds to negative 5 and multiplies to positive 4? Okay, well, it's negative 4 and negative 1. Yep, 1. If I multiply these two, I get my positive 4. And if I just combine them, I get my negative 5. And of course, I put x to the power of 1 here. Okay, so I put whatever is in the middle because this is double. It goes 2, then half of that is 1. Okay, I put my 1s there. Look what they gave us. They gave us a 4, and half of that is 2. So I'm still going to use my middle term. So instead of this, I'm going to put 2's here. And the thing, and these are both dots. These are both differences of perfect squares, meaning this can be x plus 2 times x minus 2. That's this one right here. And this one is x plus 1 times x minus 1 right here. Now it is factored completely, and that's your answer. Woo! That's kind of stinky. Okay, 32. This is kind of different. I haven't seen this before. But let's do it anyways. Natalia's teacher has given her the following information about angle theta. Theta has to be between pi and 2 pi. And cosine of theta is radical 3 over 4. Explain how Natalia can determine if the value of tangent of theta is positive or negative. Okay. First of all, let's do something here, children. Let's do something. On the unit circle, and we did a problem like this in multiple choice. Okay, all students take cookies or calculus. Okay, these letters represent what is positive. Okay, notice this option right here. My cosine is positive. Okay, so what quadrants is cosine going to be positive? Well, in quadrant 1, they're all positive, so it could be quadrant 1. In quadrant 2, only sine is positive. Cosine and tangent are negative. I don't want this, so it's not quadrant 2. Tangent in quadrant 3 is the only positive. Sine and cosine are both negative. I don't want this, so it can't be quadrant 2 or 3. Quadrant 4 Cosine is definitely positive, so that's another option. So it's either 1 or 4. It's not going to be either one of these. All right? So here's the other thing. Between pi and 2 pi, I hope you know this is 180, and this is 360. So if I start at 0 degrees, here's 90, here's 180, here's 270, and here's back to 360. It has to be between these two somewhere. It can't be in this one, which we already said no, and it can't be in this one. So which quadrant between 180 and 360? The only quadrant left is quadrant 4. I've already canceled this one out. So my degree, my angle theta, if I were to draw this, has to start here, and it has to end in this quadrant. It has to. That's angle theta. Okay? Get rid of all this stuff here. This is unimportant. Okay. So they're asking me, is tangent positive or negative? Well, in quadrant 4, we've already went over this. Cosine is the only positive. That means sine is negative, and so is tangent. It's negative. So determine if tangent is positive or negative. It's definitely negative. We need to explain. Okay? And let's write up something nice and neat. That's fine. Okay? If cosine of theta, or I could say since, because they gave us a value for it, is greater than 0, or it's positive, the only quadrant between pi and 2 pi where cosine of theta is greater than 0 is quadrant 4. And tangent is negative in quadrant 4. Or if you want to say tangent of theta is negative. But the tangent function is negative in quadrant 4. So, and tangent of theta is negative in quadrant 4. You're good to go. That's your explanation. Okay, if you're given that cosine is positive, the only quadrant between pi and 2 pi where cosine is positive is quadrant 4. I mean, really, you don't even have to write this part because you state it here. The only quadrant between pi and 2 pi where quadrant is positive, or excuse me, where cosine is positive, is quadrant 4, and tangent is negative in quadrant 4. Boom, done. You're welcome. I will see you for the tougher, okay, the short answer problems that are more than 2 points. That will be the last video. Bye-bye.
Don't forget to subscribe and ring that bell.